Okay, so if you're a sci-fi fan, you've definitely heard of this idea before, recycling every single drop of your body's moisture just to survive. But what if I told you that this concept has jumped right off the page and into the labs of our top space agencies? Let's get into how this sci-fi staple is fast becoming a space-age reality.
And yeah, for a lot of us, this whole idea starts with one of the most iconic gadgets in all of science fiction, the still suit from Frank Herbert's Dune. It's this full-body suit you'd wear on the desert planet Arrakis, and it's designed to capture everything, your sweat, your urine, filter it all, and make it drinkable again. I mean, talk about the ultimate piece of survival gear.
But, recently, when a new prototype spacesuit made the rounds, the internet did what the internet does. A user on Reddit jumped in and said, hey, wait a minute, this isn't really inspired by Dune. They made the point that, well, the International Space Station has been recycling wastewater for decades.
So this sets up a really great question, right? Is this whole dream of a personal water recycling suit a tribute to our favorite sci-fi stories? Or is it just the next logical step for a technology that's already working up in orbit? Well, the answer, as it turns out, is a little bit of both, which is what makes this so fascinating.
Okay, so let's tackle the science fiction side of things first. Because yes, a team of researchers who were directly inspired by their love for Dune have actually designed and built a prototype for a real-life still suit.
And what's really cool is when you put them side by side. The fictional still suit from the book recycles both sweat and urine, and it's all powered by the wearer's movements. This new prototype, on the other hand, just focuses on urine for now, and it runs on a battery. It's a really practical first step, taking something from fiction and making it actually function.
And listen, this isn't just some concept on a napkin. The specs are real. We're talking about an undergarment that weighs about 8 kilograms, and it can take urine, filter it, put back in the essential electrolytes, and then give you half a liter of clean drinking water in just 5 minutes. For long spacewalks on the moon, this would be an absolute game changer.
But that Reddit user was definitely onto something. Because while a personal suit is a new idea, the technology behind it has been a reality for years and years up on the International Space Station.
Seriously, for over 2 decades now, astronauts on the ISS haven't needed constant water deliveries from Earth. They've been living with this super sophisticated recycling system that proves this whole idea isn't just possible, it's absolutely essential if you want to live in space long term.
Now, the heart of this whole operation has a name. It's called ECLSS. That stands for Environmental Control and Life Support System. It's a really complex tangle of machines, but a huge part of its job is to manage the station's water, pulling it back from every possible source.
So how does it actually work? How do you turn yesterday's coffee into, well, tomorrow's coffee? The process for getting water back from urine is this really cool 3-step journey.
First up, the urine processor uses a centrifuge and a vacuum to basically boil urine at a really low temperature. That separates out pure water vapor. Then, that vapor, plus any moisture from the crew's breath and sweat that's captured from the air, goes into a water processor to get filtered. But the real breakthrough, the part that's a total game changer, is the new brine processor. It literally wrings out every last usable drop of water from the salty gunk that's left over. And the result of all that tech is staggering. Thanks to that new brine processor, the ECLS now gets back an incredible 98% of all water on the station. That is just a massive, massive milestone for making spaceflight truly self-sufficient. Okay, let's just get it out of the way. The yuck factor. I know what you're thinking. But as NASA's Jill Williamson puts it so perfectly, the crew is not drinking urine. They are drinking water that has been so intensely filtered and cleaned that it is actually purer than most of the tap water we get down here on Earth.
So we have a personal suit in the works. We have a station-sized system that's nearly perfect. Problem solved, right? We're good to go? Well, not quite. That next giant leap, heading to the moon and then Mars, that brings up a whole new problem.
And here's the catch. All those amazing systems on the ISS are engineering marvels, but they were built specifically to work in the weightlessness of space. They rely on things like centrifuges to separate liquids. But on the moon or Mars, where you have some gravity, those systems just won't work the same way. We need a whole new playbook.
In this chart right here shows you exactly why that new playbook is worth writing. Just look at the weight savings for a 30-day mission. An open-loop system, that's the first bar, where you just launch all the water you need, is unbelievably heavy. But look what happens when you use a regenerative system. It dramatically cuts down the weight you have to blast off from Earth.
So this problem has kicked off a whole wave of innovation.
Engineers are dreaming up this next generation of systems for partial gravity. You've got concepts like the planetary urine processor, which cleverly uses gravity instead of fighting it. And there are even systems that use microbes to clean water, basically mimicking how nature does it right here on Earth.
But really, the ultimate goal here for surviving on another world long-term goes way beyond just water. The real dream is to create a fully closed-loop system where absolutely nothing is wasted.
Just take a look at this diagram of the current ISS system. See those purple and green lines for phosphorus and nitrogen? Right now, after the water's been pulled out, all those valuable nutrients in the urine are just thrown away. And that's a huge missed opportunity.
So the next big frontier is a system that stops seeing waste and starts seeing resources. Imagine a system that doesn't just give you clean drinking water, but it also pulls out those nutrients and turns them into fertilizer, so you can grow fresh food hundreds of millions of miles from Earth. Now that's how you truly live off the land on another planet.
And that brings us to one last thought. This absolutely extreme challenge of keeping people alive on Mars is forcing us to invent the most efficient life support systems you can possibly imagine. So if we can actually perfect the technology to recycle every drop of water and every single nutrient in the harshest place imaginable, what could those same ideas teach us about living more sustainably right here, on Spaceship Earth? From the deserts of Dune to the vacuum of space, it really seems like the future of exploration, and maybe our own planet, depends on valuing every single